AB Calculus Note Card, 68th Fundamental Theorem of Calculus. This is the 68th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed the note card system. If the function f is continuous on a closed interval from a to b, then the function big F of x equals the integral from a to x of little f of t dt has a derivative at every point x in the interval from a to b, and the derivative of big F with respect to t equals d dx integral from a to x of f of t dt equals f of x. So it's like you take this x and put it in here, replace that, and this thing transposes to f of x. Except if you have a composition of a function, so if you have something other than just plain x, you have the u goes in here, plus you take the derivative of, first derivative of u times the f of u, and let's examine some problems to show what that looks like in actual practice. Oh, before we do that, I do want to mention that this lower limit, a, does not figure in at all. So it's like you replace this t with this x, but this a, this constant at the bottom, the lower limit, is inconsequential in the second fundamental theorem of calculus. Let's go look at some situations here. For big F of x equals integral from 2 to x of 1 over 3t squared dt, find big F of x. And then big F of 2, f prime of x, f prime of 2. We're going to do these sequentially. I'm going to go put part A down here, and what we're going to have is the integral from 2 to x, and we're going to take that 1/3 and bring it out front like this, that over 3, and this 1 over t squared is going to become t to the negative 2 power dt. Now we're going to integrate. Going to the right, we have that 1/3 here, and then we have this t to the negative 2 plus 1 is negative 1, and we divide by what we raise the power to, negative 1, and we're evaluating between 2 and x. And working to the right, we're going to have, using fundamental theorem of calculus, f of b minus f of a. Well, f of b, well, first of all, this divided by negative 1 becomes negative 1/3, and this t to the negative 1 becomes, well, it'll be t to the negative 1 power is like 1 over t. So I'm going to put this t down here as x. It's the f of b, right? Okay, next, minus, we have negative 1/3, and we have f of a, well, a is 2, so we have 3 times 2. So that's f of b minus f of a. So what we have is negative 1 over 3x, and that's going to be minus negative 1/6. So that'll end up being plus 1/6. Okay, so that is going to be our answer. So I'm going to put -1 over 3x plus 1/6. Now, as we go to the right here, we're going to find f of 2, and to do that, we're going to plug in 2 for this x, so that's going to be equal to -1 over 3 times 2 plus 1/6, and that's going to be -1/6 plus 1/6 is equal to 0. So that is going to be it. Big F of 2 is 0. Now, if you think about it, it really makes sense that it should be 0, because if you remember Notecard lesson 63, I think it's integration properties. If you have an integral from a to a of f of x dx, that answer is going to be 0. And so if x is 2, what you have is the integral from 2 to 2. So looking back, that should make sense. Next, f prime of x. Well, now we are to the second fundamental theorem of calculus. So we're going to take this x and use to replace this key here times the derivative of x. So our answer here is going to be 1 over 3x squared times the derivative of x, which is 1. So our answer is going to be 1 over 3x squared. So I'm going to put this down here, 1 over 3x squared, using second fundamental theorem of calculus. And f prime of 2 is going to be equal to 1 over 3 times 2 squared, which equals 1 over 12. So that is going to be our answer for that one. So we have all of our answers to these 4 situations here, and I hope they make a little bit of sense. And again, this lower limit of 2 does not factor in at all when we do answer choices C and D. So what this is, it's equivalent to when you take the derivative of a constant, it's 0, kind of gets wiped out. So I'm sure there's a better way to explain that somehow, but I don't have the time or patience to go into that explanation right now. To evaluate d dx, the integral from 2 to x of 1 plus t squared dt. Well, again, using second fundamental theorem of calculus, we take this x, replace that t there with x. So we're going to get the square root of 1 plus x squared. And that'll be times the derivative of x, which is 1. So that is going to be it. So it's almost like the d dx and integral cancel each other out. That's one way of looking at it. Next, our last problem we're going to look at is number 3, find f prime of x if big F of x equals the integral from -pi/3 to x cubed cosine t dt. Well, again, it's going to be like big F of x, okay, is equal to d dx. Okay, and we go back to what we have here. Big F of x and we have this, and so df dt is equal to d dx. So f prime of x equals d dx of this integral here. So we take this x cubed, replace this t, and we're going to be multiplying that by the derivative of x cubed. Okay, so I'm going to work this out below. So we have, our answer is going to be the cosine of x cubed, because x cubed replaces that t, times the derivative of x cubed, which is going to be 3x squared. And we can rewrite that, putting the 3x squared out front. We have 3x squared cosine x cubed. Okay, again, I want to emphasize that this lower limit, this constant, no matter what it is, becomes inconsequential as you employ the second fundamental theorem of calculus. And there we go. That's it. I hope this has been helpful. Good luck, and thanks for viewing.